we'll see if Sebastian is actually able to join us, given that there looks like there's some kerfluffle about time zones. Um, but if not, it sounds like yikes, you're half a setup for it.
Yeah, I might be able to do a backup. Like let me try and think of where. Yeah, did I think I dropped like the little presentation on Claude skills a couple weeks ago.
Hmm.
And part of the way that I was constructing that skills setup was orienting around a few different papers, one of which was the paper that it seems Sebastian has replicated. So got some. If that's a thing of interest, then I certainly can probably pull up a backup here.
Well, I just
Got the
at mentioned him. I don't know if he wasn't able to do it on this time or I hate time. I literally hate time. Like if we could just destroy all time zones and all of that.
I got you. We're gonna get rid of this whole timeline. Don't worry, don't worry
I
about it.
mean, and also just the whole getting dark early thing. Like I wrapped up work on Monday, the first day I was working after the time change, and it's already dark out. I'm like, thanks, I hate it. Like
Yep.
I
There's
don't.
it's pointless literally now too. Well, yeah. I don't know if anybody's familiar with that, how that story goes, but the idea was people used to like turn stuff off late at night. They don't anymore, so it's literally pointless and doesn't do anything. That was the whole point of it before.
Yeah, I always want it light later. I don't care if I wake up and it's still dark personally. I'm a morning person, so it doesn't like. I know there are people who struggle when it's dark until later in the morning and they do it. I'm always up before it's light anyway, so it doesn't matter that much, but it really bums me out if I finish work and it's dark. But
I could see it. I don't know. I am, yeah. I am the night person, so it's literally just always dark
there you go.
in my life.
Cool. Well, I'm not seeing anything from Sebastian. If he does end up showing up, that's awesome. If not, yikes, do you want to run us through some stuff?
Yeah, let me pull up my see what I got here.
Awesome. I'm gonna go off camera and eat some lunch because I was stuck in a
Do it.
meeting before this as well.
Do it, do it, do it. Okay, let's see. Let's see what we can do here. That can go down there. Let's do, can we do a new window? Maybe? Maybe that'll work. Okay. Let's take that and we'll do, we go to Notebook LM. That's where I started with it. This guy. And then I'll grab my old presentation too in case that's of interest. No, I want this. I want you to open it in this browser. Thank you. Okay. 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 And then let's see. Okay. Got it. Okay, and then that. Let me see if I've got something local to push there too. I probably do. Z.Quad. No, that's the wrong one. Proj. Okay. Gets how many branches do I have for this? Is that extra one? Okay, what were you doing there, Claude? Were you doing something in theory, I guess? Okay, let's go zproj, let's go cd Claude, then let's go nvim here, and we can go there, and then that can switch us over here. Maybe, maybe. maybe we go, and we take this and put it there. And we take this, and we got it here. Okay, cool. ACE. And give me, oh yeah, let me see, ACE, Agentic Context Engineering, papers with code. Okay, brief detour for setup here. Oh my God, how fucking annoying. Give me code, give me papers with code. No papers with code yet? Okay. One on Catalyze X. Oh yeah, I remember now. I remember. Okay. Got it.
Should we do you want to show us some of this?
Yes,
I'm
now I'm
honestly
ready.
finding like listening to your stream of consciousness is kind of entertaining.
I
I
love
don't
it.
want you to show anything secret, but like it might be fun to just tag along with that too.
Absolutely. No, we're in business now. Okay, so I was putting everything together. Let's see. What can you guys see right now? Let's see, where's
The
my
dynamic cheat sheet.
okay. Why? Okay, I guess I'll just switch this source over to my browser then. Yes, dynamic cheat sheet. Okay. So, um, give me blah blah. Stop with that, you little monster. Give me an overview of the ACE paper. Let's say I was trying to replicate the codebase. Okay. Um, the paper that Sebastian replicated and is now providing as a service is this paper called Agentic Context Engineering, Evolving Context for Self-Improving Language Models. I found this paper similarly interesting in that we're all kind of on that sort of context engineering kick, if you will. And I happened to discover this paper around the same time that Claude skills came out. So I thought a good exercise would be to build my initial Claude skills configuration around sort of this paper and then concepts related to this paper. The way that I did that was having okay, cool. Was finding, so I found some collection of papers. Let's see, where's a good starting point? So Claude Skills came out. My thought was, if anybody's read the Voyager paper, it was kind of a throwback, if you will. Back in kind of like the baby AGI era. And what that paper demonstrated was that if you give agents a skill library and then put them in an environment and tell them to go forth and play around in said environment, by the way, you have a skills library. In fact, maybe a good paper to pull up. Voyager. Oh yeah, this guy. Oh, I don't have a HTML, unfortunate. So if you give them a skills library, an environment to be open-ended in, and then a way to kind of build that sort of skills curriculum, they tend to be fairly competent at exploring environments, at least in Minecraft. So you can see this kind of, you can see this little diagram down here of the basic premise behind the Voyager skill library. And as I don't recall the date of the paper. We have a date on this. Yeah, 2023. So this has sort of been an idea for a while. And this was sort of the initial kind of formulation. There's three components. We have curriculum. So basically you're sort of treating your Minecraft environment like a classroom. And you are creating lessons for yourself with exercises about the classroom that is your environment. And then you are storing the results of your lessons and exercises into a database. And then when you run into a similar kind of lesson in your environment, you can query your skill database and see if you've already learned that. And it turns out if you kind of give it this little loop, you can have them run around in whatever action space you give them and do stuff. And it tends to be at least I don't remember the exact findings here, but I remember it being like fairly competent. It can go and like build complex things given directives in Minecraft, et cetera, et cetera. So that is sort of the basic kind of primitive conceptually. The sort of, I guess you might phrase it as like the modern iteration of a similar principle can be found in this paper. And this paper is actually a follow-up to an earlier paper called Dynamic Cheat Sheet. So as we, since we have a handy diagram, let me see if ACE has a diagram too, and we can compare all the diagrams. ACE playbook. Yeah, there we go. Okay. So here's the old way. Here's the middle of the road way. And then here's the modern way. And these are all kind of doing the same thing. They're like, okay, if we put you in an environment, and how do we get you to onboard into that environment effectively? So initially, this is fairly naive. It's like, okay, do a thing, save the thing, and then make a new lesson. Simple works, kind of effective. This one is let's see, store and reuse insights across queries. So this one is an iteration on the theme. So now instead of just a skills database and we have to kind of figure out what we want to query, we have a little cheat sheet on top of that. That's like, hey, you're building a house. Here are the lessons and skills that are going to be relevant for creating doors or blocks or mining the right type of block that looks good in your floor of your house or whatever. So you have a little cheat sheet. You're going to get an input query that's like, hey, this is kind of your next thing to do. So model has a cheat sheet, user has a prompt. You combine those two, you send it to your language model, and then your language model takes both of those and sort of goes over and looks into the memory curator. So it's going to say, hey, now that you've given me this prompt, I'm going to update this little cheat sheet, which might include relevant skills, et cetera, for whatever it is I need to do. And then I'm going to go start doing it. And we're going to just kind of keep looping this, and I'm going to keep getting different directives and sort of looping my way through it. So the other paper that comes to mind, context engineering is more effective than fine-tuning. I don't remember the exact name. Oh my God, Atlas, you suck. Find me the paper. The evolving context for self. Okay, so maybe it just is this one. Let's see. Yeah, so approach mimics the cumulative experience-driven learning characteristic of human cognition. So that's what we're after, effectively. The problem with language models is every time you open a new chat window, they are brand new, fresh little babies that know nothing. And we want to not have that happen, at least if I open it and I'm working at my job with it today versus me opening it tomorrow. It should have done some cumulative experience-driven learning between those 2 days, ideally, and currently it does not. So that's sort of our issue. The iteration on the issue. So first, let's let you build a curricula. Second is let's give you a little cheat sheet for while you're working where that curriculum might be relevant. And then third, now we've sort of built this sort of idea into a framework, if you will. So we have a structured division of labor across 3 roles. We might recall this, 3 roles. The generator is producing the reasoning trajectories. The reflector, which distills concrete insights from successes and errors, and then curator, which integrates these insights into structured context updates. So the generator produces the reasoning trajectories. Okay, so do we have a generator here? Okay, yeah, so now our cheat sheet is called a context playbook. That's in pair with the query, and those are going into our initial generator, and then that generator is going to do a reasoning trajectory. So now instead of just saying, hey, you can go do the thing, and when you're done, go back and update your cheat sheet, we're going to say, actually, why don't you reason about what you are going to do? And the advantage there is that rather than needing to go out and do the failures, now the models are kind of smart enough where they might catch these failures early. If you'll know, I know that Codex tends to do this a lot in its reasoning streams where it goes, but wait. There's also, I think, I can't remember if we experimented with it when entropics was kind of a thing, but there's some case to be made for periodically into a model's reasoning stream just injecting, but wait, because they will go back and that will trigger a self-reflection because of when usually when people say but wait, the next thing that they say after is the thing that I wasn't thinking about that I should have been. And we want the model to do that if it's relevant, but we don't want it to confuse itself. Which is why we have our reflectors. So after you think about your trajectory, we're going to send that to another model to reflect on what that trajectory contents was, and if there's anything that we want to sort of potentially put into cold storage. So we have like, hey, you secret robot brain / human brain, or robot brain that we were trying to make act like a human brain. Now that you finished thinking about what you're going to do, and we finished distilling that into some memories or lessons that are potentially useful when you're thinking about what you're going to do, now we are going to curate those sort of observations, memories, etc., into and figure out if you're kind of done thinking and planning about the thing, or if any of these little insights that you were proposing are not actually good enough, or you already have them, or what have you. Or if there's any like novel insights that are going to be useful in this task you're about to perform, provided that task is sort of going down this trajectory that you thought about first. And then we'll run this loop to build up the correct context that we're going to need. And then eventually we'll kind of let it loose and have it go, give it a try, then put it back into the loop and have it start doing this again to rebuild its playbook effectively. So the 3 sort of components here: generator, reflector, and curator. And then the limitations of prior methods. Let's take a look. Context adaptation methods is brevity bias, the tendency to optimizations to collapse towards short generic prompts. Interesting. And then what about brevity bias and context collapse? Do we have like so that's brevity bias. Do we have like a context collapse here? There we go. In case study on App World, context collapse, which arises when an LLM is tasked with fully rewriting the accumulated context at each adaptation step. As the context grows large, tends to compress it in much shorter. This is true. Arises when it's fully, yeah, so you don't want it to rewrite its entire context every time, because it's going to end up hitting that brevity bias and sort of reformulating that context packet that you're building for it in an effort to try and compress things and make them more succinct. It starts losing actual content that it needed, because it's not very good at doing that sort of judgment process. So the uh, uh, let's see. Yeah, so addressing the limitations of those that we just went over, the innovations is the reflector, which provides evaluation and insight extraction from curation. Okay, so this is interesting. I wonder what the case here is for why we think reflector fixes these problems. Improving, okay, sure. Incremental delta updates. So this will address that brevity bias context collapse thing, in that rather than having it reformulated its entire package, we're just going to say, hey, like, here's your context playbook for this task. Whatever you came up with, just diff it. Like, give us a delta update on how we're going to change this document, rather than letting you go and rewrite the whole thing. Yes, I totally would. Wander around a party in VR chat staffed entirely by language models, and just randomly walk around and yell "but wait" at them and see what happens. I think that'd be a lot of fun. Delta updates replace the costly monolithic rewrites with localized edits. Yes, so I don't know how Claude, I think Claude Code used to work like this, where, and I know Claude Web did, where rather than editing a file, it would just rewrite the entire file every time, which is just like, A, unnecessary, like, why are we doing that? And then B, like, the reason we're doing that is to make the performance worse, I guess, because that's literally the only thing it does. And then we have the growth. Yeah, exactly. The Claude artifacts do that a lot. And yeah, so like, why are we introducing all these extra places to make mistakes? Just tell it to give you a delta on the thing, and then it won't be paying attention to all this extra stuff. So grow and refine mechanism is kind of the thing that we're after. We want the model to be able to grow and refine its ability to accomplish the task. So balance the steady context expansion with redundancy control. So this paper, and in fact, if I remember right, I think they actually include the prompts in this paper, if I'm not mistaken. Let me see if I can, actually, I have it in my notebook. Does ACE have the prompts it used in the paper, like in an appendix? Okay, so when I was thinking about skills, I was like, I remember Voyager. Dynamic cheat sheet is kind of cool. And then all of these this argumentation here, the logic here makes sense to me as to why, what problems we have with models on long horizon tasks. And these seem logical in terms of how they would sort it. So the sort of baseline of where I went to build the notebook was like, okay, I agree with the, I agree with these enough to want to try them, because the thing that I definitely a million bazillion percent want is this grow and refine mechanism in my coding agent. I don't want my coding agent to start fresh every day. I want it to be growing and refining alongside me, because hopefully we will both be increasing our understanding of the code base over time instead of just me. So in an effort to do that, and after finding the sort of collection of papers and then doing, fun fact, do this more often, related papers, influence flower, core recommender archive. The flowers are very nice. Okay, this one might not have it. I'm curious. But if you want more stuff, yeah, it doesn't update flower maybe. If you want more stuff, I highly recommend trying these sometime if you haven't too many times. So it is quite helpful stuff. But I ended up finding a bunch of papers that are related to that. So let's see. Okay, we have a nice little playbook of what this framework is. And I imagine, I'm quite curious to see what Sebastian's approach was to putting this framework into code effectively. So this is like a little note on how we might replicate this paper. Execution, creation, application, replication components, etc., etc. I'm actually going to pin this so I can do it later. Source confirm provides the prompt. Okay, sure. And you print those prompts out exactly if they're found in the paper. So I put ACE into a notebook and more or less kind of gave it this prompt of like, hey, I want to replicate this, and here are some of the tools that are already in my toolkit, i.e., here's my Claude MD, here's one of the tools that I use for memory called Beats. Here is droid exec, which is going to be part of my little plan that I have. Here's OpenSpec. This is another thing I use. Here's Serena. Here's another thing I use. So I gave it the context of that, gave it this paper, and I think dynamic cheat sheet as well. And then some other papers that I found that were related to the topic that I just sort of had lying around. Sources contain exact prompt primarily. Yeah. So they actually have the full prompts for this sort of framework sitting there in the paper. So if you wanted to just sort of hack it in real quick, you can just grab the prompts from there, throw them at your agent, and see what happens. I probably should have done that, but I already had papers in mind for stuff that I wanted to integrate, so I was good to go. But I sort of went through things that I had lying around that were related. So there's another sort of long horizon reasoning thing. There is dynamic cheat sheet. There's early experience, which is from Meta Superintelligence. Yeah, that was one of their recent papers that came out that week. RPG is the one I still have on my list to replicate. Actually, I should check and see if the GitHub is up for that. And then I happened to be doing a paper on this, or I happened to be doing a presentation on this at the time. And while it's not strictly relevant, because this talks about training a new model architecture to address the problem that LLMs are not capable of solving recurrence complete problems with sufficient true depth, which is terms defined in this paper. Highly recommend to read if that sounds interesting to you. But the basic idea was since they're backprop, since they're feed forward only, them being able to like go back and reflect, or being able to genuinely compute all the way through something that needs multiple actual computation steps in order to solve, i.e., it's like computationally irreducible, where you can't estimate the computations that need to be performed. You have to actually perform them in order to get to the next state that you want to perform then. That process is mechanically impossible for language models, so they have to just estimate. Oftentimes they'll get it right. But the reason that they, or like the way that sort of occurred to me to kind of mitigate this is to construct their information pipeline in such a way where it sort of forces them to try to be as recurrent as they can effectively. And then I have a couple of other like interesting little like, oh, this could be prompt optimization type stuff. And that's how I ended up saying, okay, with this notebook, I want to take this, and then I want to use Claude Skills, which is his new little feature, and I want him to be able to build himself a playbook and leverage his existing config to be able to perform these kinds of tasks. So I ended up doing a presentation on skills, et cetera, et cetera. And while I was doing that, yeah, so while I was making this presentation, it would happen to be, I just worked out of the same notebook. And was essentially trying to set up my Claude config. So like I have my .claude folder, and I was like, okay, I'm gonna make a new repo, and it's just gonna be my .claude, and what it's gonna do is be sort of the get-backed basis for giving it this sort of context playbook building ability. Um, so there are a number of concepts involved in here, and I imagine uh, 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 what Sebastian has is code that's gonna be fairly drop-in to do the kind of reflection that they outline in this ACE paper. Uh, I have since been distracted from my quest to go actually get that. I think it's actually done. I need to just like play around with it a little bit more and get it deployed into my Claude config. But yeah, so the way it seems the way that Sebastian has approached that is by making a framework itself. And essentially what I did was try to adapt the same concepts into the existing framework of skills that is already compatible with Claude. Yeah, so I guess does anybody have any questions, comments, thoughts, concerns? Are they doing anything related to getting Claude to organize its own context other than like go grep stuff, LOL? Um, would be my, I guess, prompt for the class.
So I've been experimenting with some stuff around this week. Actually, I built a just a little knowledge graph implementation on Elasticsearch and kind of
Okay.
gave our little agent implementation both ways to store facts that it infer, relationships in their entities and then load them. Um, it was pretty interesting. It's still very prototype. I'm like trying to iterate on it now. But I do think there's tremendous amounts to be gained in terms of getting the agents to kind of learn themselves. The thing that I ran into there, and the thing that I think is maybe worth thinking about is like kind of problems around validating what it thinks it learned. And in particular, like in our agent context, we're doing a lot of like reading stuff from Google Docs and doing things, and it would like infer things from that and be like, oh, this is true. And I'm like, no, no, that's actually not true. Like and I
Interesting.
could see that because I was going into it and I'm like, or that was true a year ago when that document was written, but that is not
Mhm.
true now, or all those other things. So I think to me, like one of the gaps is like, how do we insert some sort of confidence and validation in the stuff that's being learned?
Absolutely. Yeah, I think that is the key. So initially, it was play Minecraft. If you can play Minecraft, then you're valid. If you can't play Minecraft, then you're not. Um, this one, I think this is where they ran into that same problem with you, where we have the dynamic cheat sheet and we can do some context curation. But if we notice, oh, okay, so these guys did have the curator here. So basically, their approach to solving that problem is like LLM is judge. And hopefully that will catch all of the hallucinations from the Google Doc. Um, I also noticed, or like, I've been running a lot of deep researches the last few days. And I don't know how often, if you guys are deep research users, how often you click into the cited sources. But lately, I've been trying to find the figures that the model is giving me, and like at least half the time, they're either for completely different things than the model is putting in the report, or they're entirely fabricated. One of the two, which is interesting because I used to sort of leverage deep research a lot to get familiar with things, but I'm finding it actually might be more effective for things with which I am already familiar. Because
The
it
story of LLMs in
right.
general, and also never trust their numbers
Yes.
because semantically, one number is the same as another.
Hmm. Yes. In both, it, which impacts both their ability to do math and their ability to just write numbers correctly, which is quite a handicap if you're trying to to organize Google Docs by date, for instance. And yeah, so I think their innovation, let's see here. So I know DC is direct iteration on into ACE. Looks like generator, trajectory, reflector, and then curator. Did they not memory curator? But they didn't have a reflector before. Okay, so maybe, so presumably, this is why instead of, hey, you have a cheat sheet, you can work, you should just use it while you're working. Presumably, the idea would be, hey, generate a trajectory for this task, and then I'm going to reflect on that whole trajectory and figure out what it is that you're hallucinating. So I'm wondering, my intuition on what they're doing to address that problem is probably keeping it in this reflector loop, would be my thought, for a few different iterations, such that if there are real facts it's taking out of this Google document, and it runs that trajectory down 3 or 4 times and always gets reflected on, then hopefully it doesn't consistently hallucinate the same number across each rollout of the trajectory. And that's what we'll kind of use for validation, in that we can fuzzy catch it with the reflector, and then maybe the last pass curator when it will keep it from actually making it all the way onto that playbook. But yeah, I think that the validation, yeah, I think the thing that you want from an agent that is performing a long horizon task is the ability to do self-validation and verification, have some kind of gate where for things that are going to explode something, then it has to call you before it synthesizes its insight at a certain level, and then the time between LLM has presented me a sensitive thing and I have validated whether the sensitive thing is going to blow anything up or not is as small as possible. Because you still need that loop at some point in this sort of like nested loop pattern. But the goal would be to not have to manually do it every time, because you're just going to end up bottlenecking the model there. So you need strong validation such, which is sort of what occurred to me as well. In that a good, for mine, I incorporated some of the ACE stuff, but it also occurred to me that yes, like I want more validation. So that's where I started pulling in the other sources that I have here. Of some of them where I remember this being a validation thing, specifically Compass is the one that comes to mind. And then the rest of them I know are working on memory problems for long horizon tasks. So presumably they'll have approaches in there too. In fact, maybe let's check. For all, actually, so what we will do is we will drop everything but the papers and pull those back in. And we will say, for all of the provided papers in question, they will need some way to validate that the long-term memory being created for the agent is full of true and valid things, not bad hallucinated things. What are all of the ways that the papers outline this problem can be mitigated? Yeah, so for me, I think validation is like is definitely part of this loop. It might be another part of this ever-growing graph, if you will. Yeah, DC ACE, they mostly do self-reflection. Yes. Okay, we understand that. DC MeAgent. Okay, so MeAgent will actually do RL on the policy to discriminate between useful and irrelevant information during memory updates. That's actually kind of interesting. Novel use of RL to equip LLMs with a dynamically updated fixed length memory is illustrated in figure 2. Yeah, let's grab that paper. MeAgent paper archives. With multi-conv RL-based memory agent. Yeah, so if I remember right, this is like a smaller model, and they sort of trained in that having that little context slash memory block into the model itself. So we're actually going to give it a policy so that it gets progressively better at updating this initial block that's going to always be in context progressively over time. And then we have a rule-based verifier, accuracy or completeness. And then, yeah, make it human readable and curatable. Let's see. Also self-reflection here. And then we train, let's see. Prompted to generate a chain of thought rationale explaining why the expert action is preferable to the alternative action, specifically based on differences between the resulting next states observed in the environment. I think this is a good clue here. Lately, where I've been finding mileage with getting models to put code into my code base that ends up staying there, is trying to get them to, by and large, do plan out a delta and then follow the delta until the change is complete, and then update the primary. For me, I use OpenSpec for it, so I'll update the primary spec, but it would be update like the primary memory document or primary task informing document. Wilson is the one that for me, I think I went and tracked down something specifically for Wilson. Wilson, yes, Wilson is an interesting case, I think. Yeah, inverse free Wilson loops for transformers was the one. So these guys got quite technical with how they want to it. So LLMs are embedded in pipelines where behavioral stability is a hard requirement. Builds have to pass. Compilers seek fusions. Products promise consistent outcomes. And then in practice, we have invariance breaks, order sensitivity, seed instability. Training it away is hard, et cetera, et cetera. So what is our, okay, we have related work method. Okay. So yeah, this one is like very, very technical, but it looks like, if I'm recalling correctly, this is essentially a kind of machine learning framework that is trying to gauge the distance between, for a given task as relates to agents generating tokens, what's the delta between the tokens that should be here versus the tokens that the model actually put here. And then let's try and like test all, like give a bunch of different metrics and learnable functions to sort of define that delta. And then we'll train this. I think they actually train a model specifically here for this. Or we will use some collection of LLMs to try and find what that is, and then sort of measure distance and then work with that. Let me see if there's a better stability and reliability of knowledge integration. let's see, RAG passage ordering sensitivity with commutator maps to quantify the risk of an output changing when retrieved passages are reordered. Systems can then use that signal to preserve the ordering. So this is kind of what they're doing with Wilson, is let's take this, like these concrete things that would change, i.e., the order in which this sort of context prep bundle is being given to the agent, because we can measure exactly what happens when we do nothing but change the order. And then we'll use commutator maps to quantify how that change is going to affect the output that's being provided there. And then, yeah, we have commutators can measure pathway sensitivity between different COT templates, revealing fragile reasoning that benefits from ensemble or self-consistency. So yeah, so this is the kind of like, let's see if we can learn where that stuff is going wrong at. For me, the other approach that I found interesting and I'm like exploring is this RPG or zero repo method, which more or less the goal is to kind of take what is sort of, so if you were to take your code base, you could represent that code base as a computational, like the whole code base as a computational graph if you wanted. You would use things like you know, an AST to sort of give you a map of how these files are structured. And then there's like some other stuff, if I remember right, that you can actually, yeah. For RPG zero repo, what is the graph representation of the code base represented? I recall AST and computation graph being part of the documentation, but what is the rest? Rest. So the way that I was looking at tackling the problem was we can use Wilson to try and figure out what's going wrong. We can use ACE to figuring out what we've learned, and then we're going to try and leverage the structure of the code base itself to inform whether or not the things that the model is learning based on how far away they are from the correct or like based on these kind of Wilson-based heuristics of what could be going wrong, and then we will match that against the information that we derive exclusively from the code base to try and get to that ground truth effectively. So planning and yeah, so this is actually a different graph. So they use a dual semantic graphs with functionality and structure, with root nodes, intermediate nodes, leaf nodes. So we have like functions, files, or folders. And then we're going to have edges that both try to take into account the semantic compatibility of the pieces of code that we're connecting by the edge, and then also the computational compatibility between the two sort of nodes that we're connecting here. The idea being, if I have a code base and I'm putting an agent into it, I can generate one of these, like this file augmented graph. Then while I'm doing this initial sort of context playbook update, I can try to generate another graph of this module in the code base, i.e. there isn't code here yet, but the code that's gonna go here is gonna need to look like this semantically and functionally. And then I'm gonna take that as my basis of this is what you should be building. Now you think about it and build your context playbook for how you're gonna build that. And then as you build, we're gonna do Wilson measurements on what you're outputting such that you can, such that we will get flagged when you print something that has like an unusually high commutation on where on what on something that might have impacted LLM output, i.e., like you rearranged your entire context playbook. Wilson's going to flag that because something got out of order that shouldn't be. And then that's going to be, then we're going to have the commits that are happening to that graph that we can, like, as humans, go look at because we have a little flag there that tells us, hey, something could have gone wrong here, to go validate all of that. So, which is to say, I don't think it's an entirely complete solution for AGI, but I think that ACE is a good basis for, hey, here's like we're pretty sure that models don't have this and they need this. Here's a way to do it that we've iterated on at least one time, i.e., we used to have dynamic cheat sheet, now we have ACE. I'm quite curious as to what Sebastian puts into his framework, but at least for me, I was like, okay, how much of this stuff can we put into skills? And the basic, my thought for it was, okay, if I have this notebook and I have all this stuff that I could, in theory, put into my agent, if my agent is Claude or another CLI agent, well, why don't we take all of the possible configuration options that that agent has to build its context, i.e., hooks, interaction styles, MCPs, subthreads, a couple of specific skills for delegating, like a reference for how your skills work, and then say, hey, Claude, if you need new hooks, you can make them yourself. If you need to clear your system prompt, you can clear it yourself. If you need to change your MCP configs, you can do that yourself. And the thing that we want you to do is sort of derived from this kind of collection of tools and things that might help us solve the problem of, like, let's get this thing driving through the code base and making good stuff. Yeah, basically, yeah, like it is pretty risky. I will probably keep him in a container for for a while because, yes, Kevin makes the good point that if I give him the ability to change his own configs and permissions, if he wants to give himself permission to RMRF my home folder, then that is probably something I'm going to need to think about as well. But I think the basic premise of that Voyager paper was like, hey, why are humans configuring these things? They're much better at configuring themselves because you should readdress that configuration every time that you do something new, because your old config might work in several situations, but it doesn't work perfectly for all of them. So if we can make Claude good enough at figuring out what it needs and then give it permission to reconfigure its configuration until it has what it needs, hopefully we'll get better results. And then we can augment that with stuff on the side that's helping us keep track of what configuration changes he's making, et cetera, et cetera. Gemini in particular loves dropping databases. I have not, I honestly, I don't really, I think the only place I use
I
them.
only know this secondhand, to be honest. I have one of my engineers likes to multiplex with lots many models, likes to use
Mhm.
open code and do this a lot. And he
Yeah.
told me in particular he's run into several times problems where Gemini will just be like, oh, you don't need that database. Let me drop that.
Hey, I love it. I love it. Yeah, I think with with Gemini for me, I think the last time I really pulled out Gemini was to go into AI Studio and just dump the entire code base in there and have it make observations. I don't think I use it as part of a harness. At least not these days. Um, let's see. Cool. Well, I managed to fill most of the time. 5 minutes for any. Does anybody have any thoughts, anything you want to add to this collection of concepts and experimentations, I guess?
This is super fun. Thank you. Yikes. I currently have GPT-5 working on seeing if it can port uh, Sebastian's Python service into our Go framework and do something fun with it.
Oh,
So
did he drop a repo for it? I'm trying
yeah,
to.
he dropped a repo. It's got
Yeah.
a full Python-based implementation you can use as a either just drop in and run or hand to your agent to learn from or what have you.
Hell yeah. No, that'll be excellent. Yeah, I think I will probably I will probably do
The
something
one
similar.
downside I saw
Oh,
is that it requires temporal, so might
I'm not going to use it out of the box.
okay.
I have GPT-5. Well, first writing some architecture. Actually, at Manuel Solano's prompting, I'm using it to first doing research on give me an architecture document. How does this work? What are all the pieces? Whatever. And
mhm.
then another one based on our system. And be like, all right, how do you port this into our system? Go.
Yeah. I was
Nice.
thinking something similar and using a different workflow tool if necessary, but yes, similar idea.
Yeah, I'm currently doing that. One of my current tasks is to unslop our code bases. So I have one that is unslopped, and then I'm using that as a basis to have agents write reports of of what the unslopped one looks like, and then have it go write a report on slop degree of the rest of them. And it'll be unironically, slop janitor is my secondary title. It's my preferred way to interface with the code base right now until I'm done interfacing with it this way, and then I'll be comfortable adding code to it or removing code. Hopefully removing code. Always hopefully. First, use the Claude Code / command. Interesting. Oh, this is cool. Observe how Alice acting capital. Produce the following output in the playbook. And then I reset, let's see, explicitly confirm the presence. Reset the local state and ran it again. Now correct. Okay, yeah. So yeah, this is like the iterative reflection thing there. Yeah, no, this is cool. I am quite interested to hear. I wonder if maybe we'll get Sebastian next week, and then yeah, I'm also quite curious to hear what you and Manuel and the rest of the team end up doing with this, or if you make
We'll let
any.
you know. We're at an offsite much of next week, so probably won't make too much progress unless GPT-5 goes faster than I expect
You know,
today, and I'm able to get a prototype running. But
drop or yeah, I don't know if you guys have played with the Cursor's new model, but tell it to give you 10.
no, Composer. So, I mean, definitely been doing stuff with Composer. I
Mm,
find it is great when I know roughly what I want to or what I want to have happen and I'm working in flow.
mhm,
It is so when I'm doing it, when I want to do an interactive coding cycle and I'm just operating at a higher level than lines of code, it's phenomenal because it goes super fast. And I'm like, I want this conceptual change, that conceptual change.
mhm.
Um, when I want to do more complex things or really do a bunch of stuff, like I'm still on GPT-5 High. Like it's GPT-5 High is my baby. It does so much good stuff for me.
Do you use that in the codex harness? I'm presuming.
I've been using it in Cursor.
Interesting.
Um, their new agent UI I really enjoy and appreciate.
Are you using
Uh,
it in Cursor, the IDE, or their CLI?
I'm back in the IDE ever since 2.0. I'm back in the IDE.
Interesting. Interesting.
Um, yeah. Well, we'll see. We'll see where it lands. And partly I am switching around models, and I'll do. We have recently rediscovered the value of the debate prompt.
Oh
Um,
yeah. Yeah. I have my
and
yeah, my co-founder person has just stumbled across the Socratic debate.
yeah, and you do for that all Sonnet seems to do better. So like yeah, doing a lot of that in the cursor ID right now.
I used to have a NeoVim hotkey for that. I would just highlight something and then make them debate about it at times.
Looks. All right. Well, thank you for jumping in, Yikes. Appreciate
Yes.
you. Thanks
Sure.
everybody for joining. Please, if you have a thought for a topic, sign up ahead of time so we don't end up in the